Okay, so we have finished configuring our Django app locally, and now we're ready to deploy it to the server, which is a big win. We've done all the setup we need with the requirements and the settings and all the static files and stuff, and we're good to start uploading files. I want to show you a quick trick to help you access the server with a bit more convenience on Windows. What we're going to do is we're going to make it so we don't need to use the IP address anymore to refer to the server. Instead, we're going to give it a nickname. So to do this, we're going to open Notepad as administrator. Yes. And we're going to open a file. And that file is in Windows, System32, drivers, etc. And it's not a text document. It's just a regular unextensioned file called hosts. And this basically allows us to give IP addresses a nickname. That's one way you can think about it. So we're going to type in whatever the IP address of your server is. My server has this IP address. So, let me just double check. 64.225.23.131 looks good. And then the nickname. I'm going to call mine Tute server, because that's a lot easier to remember than these numbers. And then you just save the file, and that's it. Right, now, if I open up Git Bash, and whack some control pluses to make it big, and I try SSH root at Tute server, it's going to complain because it hasn't seen the server before, even though it has a different name. So it's like, who's this? And you just say, I trust this server. And you're in. You can see it's the same computer. We just used a nickname to address it, which makes typing in SSH and all that a bit more convenient. So let's exit out of that. Cool. Right, so before we start uploading files, we need to sort of prepare them locally. So let's go into our code Django project. Okay, so now that we've set up that nickname in our host files, so we don't have to type in the IP address again, let's get to actually deploying our code. So the way that we're going to do this is we're going to copy the code that we want to deploy into a folder, and then copy that folder onto the server. So let's have a look at the bits of code that we have locally, or sorry, not the bits of code, the folders and files that we have locally, and see what we want to copy over. So let's do an ls and have a look here. So we've got this local database file, an SQLite database. We don't want to copy that over. And the reason we don't want to copy that over is because we want to have a separate database in prod that is completely not related to this local database. So this will stay where it is. We're not going to copy our virtual environment because it just has a lot of files that we can recreate on the server, and it's kind of pointless. So we're not going to copy that. We are going to copy the requirements text file. And the reason for that is this is going to be the definition of all the packages that get installed in the virtual environment on the server. So we need this to keep track of our dependencies. And finally, we will be copying the Tute folder over because it has our source code and we need it to run. Just one thing to check though, I just want you to do a quick ls of your Tute folder and just check that it doesn't have this static files folder in it. So if you have a look at static files, ls Tute static files, and if you look in admin, actually if you use the find command, this will find all the files and static files. And you can see there's like a bajillion files in here. So if we do find static files, and wc-l just counts the number of lines that are from the last command, and this pipe signal just means take the output of this and pipe it into this command. So this will tell us that there's 147 files, which most of them are just from the Django admin, which isn't a part of our Django app. So we don't want to copy those files over. So what we're going to do is we're just going to remove static files before we copy it over. And it's not normally there. It's only there because I ran collect static locally as an example earlier. All right. So we do ls Tute, static files is gone, and we're ready to start copying code over. So let's make our deployment directory, and let's copy requirements text into our deployment directory. and let's copy recursively chute into deploy. So if you've forgotten, this -r sort of argument or flag, I guess, in the copy command just means copy this folder and all of the files and folders inside of this folder into deploy. That's what this is doing. All right, let's have a look at deploy. You can see we've got requirements.txt, we've got chute. Inside of deploy chute is some stuff. Right. I'm going to show you just a little trick I like to do. Well, not a trick, just I guess a technique or method, and that is to I guess make sure that the server where we're copying code to is clean. And what I mean by that is we're going to use SSH root at chute server. So instead of running SSH, we're going to run a command. All right. So what this command is doing is it's going to SSH into the chute server, which is our Django DigitalOcean droplet, as the root user, and then it's going to run this command. And this command is saying remove recursively force the folder root deploy, which if it exists, it'll get deleted, and if it doesn't exist, nothing will happen. So that's sort of what we want. So we're just going to run that. And that's going to nuke root deploy if it exists. And now we want to copy our deploy folder into root deploy. So we're going to scp root, we're going to from deploy to root at chute server to the folder root deploy. Let's go over this again. Using the scp command, we want to recursively copy -r from the deploy folder as the root user onto the chute server, and the target folder we want to deploy to, we want to copy to, is a root deploy. I actually think we want to do it this way. We want to say that root is the target server, sorry, the target folder, and the deploy folder will be created within root. Let's give that a go. All right, and as this is going, I just want you to note that some of the files that are getting copied over are not files that we want to keep, and that's these PYC files. I guess you could think of them as compiled Python files. They're the result of the Python interpreter running our Py files, and this is just a shortcut that it takes to run the Python a bit faster next time. We want our Py files to be the source of truth, that they should describe our code, not these PYC files. So we'll go and delete them later. Right. Now that our code is copied over, it's all done, let's go onto the server and have a look. So we can SSH into root at chute server. And we can press Control-L to clear the screen, use pwd to look at our current working directory, root, which is normal, do ls, and you can see that our deploy folder has turned up. Let's go into the deploy folder and look what's in here. And you can see requirements.txt and chute have been uploaded. There's a cool little utility called tree, which I want to use, which is just there to print out all the things in the local directory in kind of a recursive way that looks nice. So if we try it out, we'll find that it's not there. But our apt package knows that it exists and that you can install it, and so let's just install it. All right. So once we've installed it, with apt install tree, we can run tree again, and it shows us all the files that we got. And you can sort of notice all these PYC files junking up our folder structure, which is kind of lame. But you can see requirements text there, chute, counter, admin apps, models, all that stuff is there. But we want to get rid of all of these sort of compiled Python files before we move on. Now, typically, I would actually do this on the on my local computer before copying the code, but I just found it was easier to do it on the server because we have access to more Linux tools. So the way we're going to do this is we're going to use find, which is a handy sort of a Linux command line tool. And the way find works is you say find me all the files with the name that looks like something, that's the star.pyc. And this will find all the PYC files. You can see here that the only files being found are .pyc. So let's do find.pyc, and then we can pass it the -delete flag. And what it's going to do now is find all of those files, then delete them. Done. Let's run tree again and see what we have. So that's better. There's a, let me just push this up so you can see it. There's those find files are gone. We still have that annoying PyCache folder, which doesn't really do anything. And honestly, if you stopped here, it would be fine. You don't need to delete the PyCache file, but kind of annoys me. So I'm going to do find -name under PyCache. Done. Get rid of the delete flag because we want to test it before we delete it. There's all the folders. Delete. Deletes them. Run tree again. Have a look. Right, that's nice. That's just the core things that make up our Django app and nothing else. All right, so we've copied the code that we need onto the server into the deploy directory. We've cleaned out all the crap that we don't want using find. And now there's one more thing we need to do before we set up our application. And that is to convert our line endings from Windows line endings to Unix line endings. And I talked about this a bit in the blog post, which hopefully you read, and that's going to be the next thing we do. So if you don't do this, your Python files won't run. They'll just crash and it'll suck, and it's a bad experience all around. So to do this, we're going to use a tool called DOS2 Unix. And if we try to run that, it's not going to work because it's not installed. So handily, the apt package manager knows about it and knows that it can install it. So it's given us this hint. And I think we should install it. So let's install DOS2 Unix. And it does some magic. It was done. And you can see it's installed in user bin. We can do DOS2 Unix help. And it has a bunch of options. But basically the format is DOS2 Unix, myfile.py or something, or myfile.txt or something. So that's all good. The thing is that we want to run this, we want to run DOS2 Unix on all of these files. And we don't want to just manually go through and convert each one. That would suck. So we want a way to automatically traverse through this file system folder and run DOS2 Unix on every file. And I found a way to do that, but I'm not going to pretend that I just kind of invented it. Instead, I'll show you how I found out how to do that. So I realized that I needed to run DOS2 Unix, I'll call it recursively, on this folder, which is deploy. That's where I am now, root deploy. And so I went into Google and I went, what was it? DOS2 Unix recursive. That's what I searched for. And then I got this Stack Overflow answer, and I looked at that, and I was like, what's all this? And I saw this, and I was like, yeah, that looks good. And I gave it a try. So fair enough if this looks like just some magic to you. It's a lot of stuff at once, but let's go through it step by step, and I'll explain it to you. So first of all, we're using find, which we know. So we're doing find dot. If we do that, it prints everything in the directory and all the directories, and so on and so forth. One problem is it's also printing folders, or directories as they're called in Unix, and we don't want to run DOS2 Unix on folders because I think that would result in an error or some behavior that we don't want. So we only want files. And in the find syntax, which you can find more about by typing man find or find help or whatever, in the find syntax, you can only select files by just typing type F for file. And you can see here, just give you, if we find type F, it only prints out files. So now we're onto something. The final argument was find, just type F, was print 0. Now this was an interesting one. I've actually never seen this before. If I have, I don't remember it. Let's try it out. It prints all the same things, but sort of in one line. And I was a bit confused by this initially. It turns out it puts some sort of binary null character, I don't know the details, between each result. And that was so it can be passed to the next program. And the next program is xargs. So I've seen xargs before, maybe you haven't. Oh, geez, that's a lot of stuff. And it doesn't have a very helpful description, so I won't blame you for not wanting to read the help text on xargs. But basically, xargs, you pass it a bunch of strings, and then it runs the same command on all of the strings. So that's kind of what we want, isn't it? We want to find all of these files and then run DOS to Unix on all of them. And that's what we're going to do. We're going to pipe the text into xargs, and then in parallel, as much as it can, it's going to run DOS to Unix. And the last thing, this -0, is just an attempt. We're really just telling xargs all of the items that we're passing in are separated by this null byte or whatever, and that's this parameter here. And this -0 is just a way of telling xargs that's what we're doing. So expect this kind of user input. If that was a bit confusing, that's okay. You can just copy paste this command and it'll do what you want, and we can watch it in action now. So we can see it working. It's gone through every file that we have, and it's run DOS to Unix on it, and DOS to Unix has converted file to Unix format, which is what we want. So success. Cool. So we have successfully uploaded our project to the server, and we have sort of cleaned it up so it's ready for the to be run, essentially. So next thing we want to do is put it in its home. We don't actually want to run our project from this deploy directory. This is just kind of the place where we're uploading the code. And that's a pretty common pattern in deployments, where we have one folder where we dump all the code, and then we're going to have another folder where we actually set up and run the app. So to make this easy, we're just going to make a directory called app. This slash means it's at the root of the file system, and I'll show you more about that in a second. All right, so we've made a directory app, and when we ls the root of the file system, you can see there's a bunch of sort of stuff in there, most of which we don't care about at the moment, but the one that we care about right now is app, which has been created. Have a look at app. You can see there's nothing in there. It's an empty folder that we just created. So now let's copy everything from deploy into app. And so I'll do this using absolute paths. We're going to copy recursively from root deploy, which is where we are now. And we're going to do use the star syntax like that, which just means copy everything in this folder, including requirements text and the tut folder and everything in that. And we're going to copy all of that stuff into the app folder. All right, let's have a look in app now. Okay, and we can tree app and see what we copied in, and it's all the stuff that we just had before. And this is a pattern I recommend, where every time you upload your code, you delete the deploy folder, you recreate it, upload the code in there, clean it up, and then put it into app. Okie dokie, so let's go into the app folder and let's get started with our virtual environment installing Python packages. So if you recall, we've already installed pip and we already had Python 3. So we got which Python 3 on the server, and we got which pip3. And do we have virtual env installed? I can't remember. Shown. We wanted to run pip3 show virtual env. And we're asking pip3, and it's like, nah, it's not there. So let's install it. So we're going to install virtual env from somewhere. Cool. And we're now going to use virtual env and -p for the Python interpreter we want, which is the Python 3 one in this case. And we want to install it into the env folder, just like on our local computer. We have a look in here, got env. If we really care, we can see that a whole bunch of shit has been put in there. Cool, and let's activate our virtual environment. Before we do that, let's do a pip freeze just to see what we've got. Pip freeze. Oh, sorry, pip3 freeze, because there is no pip in this machine. And what's on here? A whole bunch of shit. Let's activate our virtual environment. So on this Linux machine, instead of env scripts activate, it's dot. Oh, sorry about the sounds. It's dot env bin activate, and that's how you do it on a Unix shell. All right, and you can see our virtual environment is activated. And let's do a pip install from our requirements file. Cool. If we do a pip freeze now, we should see it's just the folders that we required from our requirements file, and it's the same as on our local machine when we were running the virtual environment, which is a big deal. It's really important that they're the same so that we can expect our Django app to run the same in this environment as on our computer. Now, if you recall, when running our production settings, we needed to set Django settings module so that Django knew to use our production settings. And we also set our secret key. Now, those environment variables aren't set here. And what I want to do is show you how to set them permanently on this machine so you don't have to keep adding them again and again. And so first I'll show you how to print environment variables, print env. And it prints out, what is it? User root. The environment variable log name is root. This environment variable lscolors is really long and has lots of stuff in it. So that's all the environment variables that are available in the terminal right now. And we will be using printf env again to check our work. So the way that I need to figure out how to turn that off, sorry. Oh well. The way that we will set this is using the etc environment file, like that. So let's have a look at etc. There's like a bajillion things. And in the etc, we can see that there is an environment file, which is good. And we're going to open it up with Nano. So Nano is like a text editor that you can use from the command line in Linux. And I find it the easier one to use out of the available options. So let's do Nano etc environment. And we're going to edit this file and set these environment variables permanently. All right, so there's already something in there, this path variable. Let's not screw with that. Instead, let's add our Django settings module. Did I spell that right? So module, environment variable, and we're going to give it the string that we used before, tut.settings.prod, so that we're always going to use the prod settings. And we also had our secret key, which is an environment variable that we defined in our production settings as Django secret key. And let's just put in some long random string, 50 characters, whatever you want. Cool, that's long. And I'll put an exclamation at symbol, exclamation mark, it's pretty secret. Cool, and make sure there's a new line. And then we're going to do Control X, and then we're going to press Y, and then we're going to press Enter. And that is a weird combination of stuff, but that's how you do it. Now, if we do printenv again, it's not set. It's not there yet, and that's kind of shitty. Now, there must be some way to refresh your environment variables without doing what I'm about to do, but this is the easiest way I can think of. The fastest way to just refresh your environment variables and reload the etc environment file is to exit your SSH session, go back onto your local computer, go and just press the up button in git bash. Up allows you to scroll through commands up and down. So press up and then press enter and go back into the server. Press Control L to clear the screen. We can do printenv, and we'll see that our Django settings and our Django secret key are both there. And a quick way to do this, rather than digging through all of that, is printenv. Then we type the output into a command called grep Django. So grep basically takes a bunch of strings and then searches and matches this string. So it's just a string matching sort of filter. And you can see here it's filtered for Django, and it shows us their environment variables are set. And now we never have to think about them again. We can just assume that they're there. Cool. That is that part. So we've uploaded our code, we've cleaned our code, we've created a project directory in app. Ooh, that is annoying. Bad computer. And in app, we have our virtual environment, which we can activate, and we will need to activate every time we run it. We can run pip freeze. We can run a which Python. You can see it's the Python file in our virtual environment. It's all good. Right, let's get started. Let's start setting up our applications. So the first thing we want to do is create a database. So the way we do that is we go into Qt and we run our migrations just like we would in our local environment. So we run manage, migrate, and it will run all our migrations. And you can see here it's running content types, auth, admin. These are all built-in Django sort of standard migrations. And it's also running our counter migration there. So that's good. If we do an else, there's nothing in here. We go back one. All right, I'll just show you this. If you use the L parameter, it lists it out. So you can see here we've got our Qt folder, our requirements, our virtual environment, and our database. And this is our production database now, which will be kept separate from our local database. And the key thing that I want to point out is that we are now able to destroy this Qt folder while keeping our production database. And that's pretty important because we don't want to blow away our database by accident. Right, so the second thing we need to do is we need to go back into the Qt folder where the manage_py script is, and we want to run manage_py collect static. And that is to make sure that Django dumps all of our static files into a folder where it can then use them for white noise so it can serve static files and avoid that whole issue we solved earlier. So you need to run collect static to make sure that the static files get copied to static files. So ls again, the static files, we can tree static files to look at all the crap in there, and there's a lot of stuff in there that we never want to look at. Okay. Now we're actually ready to run our Whiskey server. Now, if you recall, we tried to run Unicorn on Windows and it didn't work, which was kind of shitty. But good news is we can run it here. So we run Unicorn help. And it gives us a bajillion options. But actually running Unicorn is pretty simple. Let me show you. So if you recall, we have in our Qt app, in our Qt project, this Whiskey file. And we're just going to point Unicorn at that to run it. So just note that we are in the Qt project, the same place as our manage_py script, and that's where we need to be to run Unicorn. I found otherwise it gets a bit weird and doesn't really work. So we run Unicorn, and then we run Qt, which is the app.whiskey, which is the Python file, colon, because we're going inside the Python file now to get the application object, which is present in the file. All right, so you can see Unicorn is running, it started, we get a console output similar to run server, and it's saying it started Unicorn version 20, very nice. It's listening at 127.0.0.1, which is basically localhost. This is just another name for localhost on port 8000. So let's try something. This is nice. Let me make this small. And see if I can just get this up a bit. Right, so it's running. Cool. One thing we can do, open another git bash. Let's do SSH root at Qt server. Log into this thing. Right. So now we're logged in as root. We're inside the server. This is inside the server. Let's see if we can make an HTTP request. And we'll use the command curl, which sends an HTTP GET request. We'll send it to localhost on port 8000. Does it work? Yeah, it does. The count is 1. So we are sending a GET request to Unicorn. Unicorn is running our Django code. It is using our template. It's hitting the database. It got out of the database. There's no counter. It created a counter, put 1 on it, and returned a response to us. So it's fully functioning. Let's do it again. Count is 2, count is 3, count is 4. So this is working. Our app is working, which is pretty fantastic. And we know it works inside the server. So now the question is, does it work when I send a request from outside the server? And this is pretty easy to do using our web browser. So we just type in the IP address of our server, which is, for me, 64.22. Oh, there it is. So you just type in whatever your IP address is. I'm typing in mine. and it should hit the server. And it refused to connect. Yes, that's right. Why? Why is this not working? So when you visit a website or like a server from your web browser, by default, it's going to visit on port 80 because that's the default port for HTTP requests. That's just a convention that we have in web development. But you might have noticed, or maybe not, that Unicorn is running on port 8000. So we need to use a different port to access this program. So let's change the port using the colon port syntax 1000. And don't make a fool of me, computer. Okay, the computer will make a fool of me. Refuse to connect. What's going on? Right. Yep, so the computer did make a fool of me. That's okay. I know what the issue is. So let's look at this. It's listening at 127.0.0.1 on port 8000. And we know it's working. We have successfully gotten it to do all the stuff it needs to do to serve web requests. But it's not working from outside of the server. It's not responding to web requests from the world. It's not obvious what's wrong if you don't know this kind of little trick, but basically the web address 127.0.0.1 means serving on the local host inside only. It's fucking weird. I don't know how to make the rules. You instead need to use a different IP address. So let's stop this. Run Unicorn, and we're going to give it the bind parameter, which you can find in the documentation if you care to look. And you need to bind to 0.0.0.0. And this basically means serve from localhost, but let requests from the outside world also come in and hit the server. So we're going to do that on port 8000 still, just for shits and gigs. It's running. It's listening at 0.0.0.8000. All good. Let's try locally. Works locally still. Does it work on the old IP address 127.0.0.0? I think it will. Yeah. Oh no, it doesn't. It doesn't like that. Okay. So it doesn't like that, but it does like this. What the fuck? Oh, this is all news to me. Okay. Okay, that's pretty interesting. So I didn't know that. If you set Unicorn to run on 0.0.0.0, it seems to not respond to this internally anymore, or this, but it does respond to localhost. And I believe that if you just run it on 127 whatever, it also responds to localhost. Yeah. Oh, today I learned. Cool. So anyway, let's go back to running it on 0.0.0.8000 and see if we can access it from outside of the server. Let's just do another test request from inside of the server. Let's go to Google Chrome, try the IP address on port 8000, and thank fuck our server is working. That's great. Now, of course, you have probably never, or maybe, I don't know, visited a website on a port. You've never wanted to type in a port before. This needs to go away. We just want to type this in. It's a bit nicer. But of course, it doesn't work because our server isn't listening on this port. So we need to tell Unicorn, listen on this port. And we're going to stop it with Control. But I'm stopping this with Control C. I don't know if you could follow that. That's probably important information. And let's change port 8000 to port 80. Just want to point something out. This we can do this now because we're running as the root user. If you're running as the root user, I believe you still can do this, but it's a little more complicated to do, which is one of the reasons we are running Unicorn as root. All right, it's listening to outside requests on port 80. Let's give it a look inside. All right, if we try localhost 8000, it doesn't work anymore because it's not listening on that port anymore. Try localhost 80. It is working. The count is now 14. That's good. And if we try localhost with just no port, it should work as well because the default HTTP port is, oh geez, or am I wrong? That is a surprise. What's happening here? Just hanging forever. Localhost port 80 is also hanging. Interesting. What happens if we try to visit the server like this? Count is 18, count is 19. So it works from the outside, like it's working, but now it's not working from the inside. This is uncharted territory for me. What the fuck? Oh, now it works. It was a mystery. I don't know why that happened. If you do, email me. I want to know. So we can access our Unicorn server from the inside of the server, and we can access our Unicorn server from the outside of the server. And as you can see, our static files are working, which is fucking awesome, because it would be a real shame if they weren't after we put all that work in to get white noise working. So we can do a hard reload. We can have a look at our network request. And we can see that it's loading our style sheet. That's pretty cool. It's very pretty, I like to think. The count is incrementing, which is nice. All good. So this is sweet. Our Django app is now running on our server. It is serving HTTP requests. You can get to it from your web browser. Yeah, there's just one little problem, though. There's one little problem. I'll show it to you. We can only run this if we're logged in through SSH and running it in our terminal. If we stop it with Control-C, our website is gone. Try again, and you can see it's trying to connect, and it's failing. The site can't be reached. So our website is only working if we are there to run it, and that's not normally how websites work. You don't imagine that there's like some person there waiting at a computer watching the website run the whole time. So we need to figure out a way in our next step of the guide how to run Unicorn so that we don't have to be there to run it. Before we get to that, one thing that we're going to do is actually two things. I lied. It's two things. We're going to run our server, and I just want to test some things out with you. Let's go into the app directory in our other terminal. See what's in there. Let's activate our virtual environment because you've got to do that. And let's go into the chute folder. Now let's create a super user. Create super user so we can log into the admin panel and see what's in there. And this is nice because it's just nice to see what's in the database of your Django app in production without having to log into the server. And the admin panel is really nice for that. And it also lets you modify data, delete things. It's pretty cool. I'll let you decide what username. I like to call it admin. It's probably a bad idea. Maybe choose something like your name or something a bit harder to guess. And I suggest that you actually put your email address in. I'm at dclaw@gmail.com because you can, oh, fuck it, I don't know why, just do it. Password, put in a real password, like something that is actually not 1, 2, 3, 4, 5. This should be secure. And I'm going to do this one. That's a real password. And you'll see it didn't complain this time about my shitty password because I put a good one in. Sweet. Let's check if that worked. So let's go to our website /admin. See, we've got the same Django admin console and all the static files are working, being served from our server. And my username will be, what was it, admin, add my nice password. And this is actually interesting. It's something we'll get back to later, but you'll see that Chrome is bitching about our site not being secure. And it's true, it's not secure. The data being sent to and from the server is not encrypted. If someone in the middle managed to intercept our packets and look at them and put them together in the right order, they would be able to see my username and password as I logged in and all the requests that I'm sending and receiving from the server. So that's something we should address at some point. But you know, in other news, we managed to log into the admin. We can see our one and only counter model. It's a bit slow. And there you go, the count is 28. If we visit the website, the count becomes 29, and then we can view it changing in real time, which is pretty cool. Sweet. And the last thing, before we get on to fixing this problem of Unicorn requiring us to babysit it, is let's check out the shell. So we go to manage PyShell. So sometimes you just got to get into the Python shell and run some scripts and check the data and delete some data. And you don't want to make a habit of it, but sometimes it's necessary. And you can do it on the server. You can get in there and run from counter.model. That's not good. Don't know what that was. From counter.models, import counter, and you can get the last counter object. Objects last. There you go. You can get the count on it. Should be 29, and you can delete shit if you want to. There we go. Let's delete some data in prod. Don't advise doing this unless you have a very good reason. It's generally good to try and not make changes to your data like this, but sometimes you're either lazy or you have to, or you have some good reason. There you go, reset the count back to 1. And that is our section on deploying the app. It's in production, it's running, it's serving requests. We just have one problem about this thing not working when we turn it off, which is kind of lame. And we will address that in the next video.